Hello and welcome to this demo of Spark Machine Learning. This is part of the Spark training delivered by CERN IT. We will be using the Spark ML API and Spark Data Frame API. And we will be using an open dataset, California Housing Prices dataset, where we're going to predict housing prices for California counties using data from the 90s. This is inspired by the paper and book mentioned in the notebook. The first thing we want to do is to create a Spark session. We'll be using local mode as it is a small data set. We're going to be reading the data. The data is available in the repository where you find the course notebooks. And I refer you to the video and documentation how to get this. First thing, and then standard technique in machine learning is that we're going to take the data that we have and split it randomly in a training and test data set, 80% for training and 20% for test. We only have 16,000 points in training, so we're going to cache it using cache and count to trigger an action for actual caching. This is the schema of the data, and then we take 10 rows and put them to pandas, so we have nice visualization. You can see that we have longitude, latitude, housing median age, total rooms, total bedrooms, population of the county, number of households, in median income, median house value, and ocean proximity. As you can see, here we want to explore the data, ocean proximity for example. We want to see it's a categorical feature. It has 5 different values. And for total bedrooms, we find that there are some missing values, 175 missing values. So we want to move on with feature preparation. We use PySpark.ml, which has some methods that we're going to use. Ocean proximity will become a hot encoded feature. We'll see later what this means if you are not familiar with it. And for the total bedrooms, we're going to fill in the missing values. Okay, we put these 2 preparation steps into a pipeline. This is a way to put the steps together, one after the other. A pipeline is an estimator. I refer you to the lecture to see the difference between estimator and transformers. So we feed it to the training data, and we get a transformer that we can use against the training data and see how the data is transformed. Okay, this is our standard data, and the ocean proximity now has become a vector with zeros and ones. This is how one-hot encoding works. And total bedrooms has also the null values fixed. We need some further data preparation. So Spark requires that the features are put together into a vector. For this we have a vector assembler that comes with the Spark ML API. And also we want to do standard scaling. So so data will follow the standard normal distribution. So a mean of 0 and a unit variance, which will help the training algorithms. We put everything together in our pipeline, which is becoming longer, and we use the same trick of fitting the training data to the pipeline and then transforming the data. So our features now are a vector of numbers. We move on and we go to the actual machine learning algorithm. We're going to use a gradient boosted trees regressor from the PySpark ML API, and we're going to add it to the pipeline. So the pipeline now has one extra step. And finally, we fit our data, trained data, to the pipeline. This takes a few seconds. We don't have much data, but still requires some iterations. Number of iterations is actually an hyperparameter of the model. Okay, training is done. If we want, we can also save the model, and we can start evaluating the model. So we'll use PySpark ML evaluation, regression evaluation. The label column is the median house value, and we will predict it from our model, and we'll compute the root mean square error as a metric for performance, and this is the result. We can also investigate the correlation matrix between features. compute the correlation using PySpark.ml, and then we plot it using matplotlib. Okay, you see some features are correlated and some are not. And then it's possible to do more advanced computations, like we can use cross-validation, which is a standard technique when you don't have much data to make the most out of it. And also we can do grid search for the parameter, for example, max iter. This will take a little bit of time. It's possible to run it, and then we'll get an improved root mean square error. Okay, and this ends our short demo. Thank you for watching.